So what we'll do, just to make it a little bit less confusing, we'll just draw one of the triangles that we have from splitting the equilateral triangling. So we knew that bottom angle was 60, the top one was 30 because it got split in half. And then the hypotenuse there is 2, and then that's side 1 because that was a side that was split in half. Now we have the problem that we don't know this perpendicular height. What could we do, Miss Hughes, to find that perpendicular height?
Well, we know it's a right angle triangle and we have two of the sides, so we could use Pythagoras' theorem.
Good idea. So be careful here because we always have Pythagoras is c squared equals a squared plus b squared. But the c squared is always a hypotenuse squared. So we know that in this case. So we'll have 2 squared equals 1 squared plus, shall we call it x squared? Okay, and then just doing a little bit of quick equation solving. We know 2 squared is 4, 1 squared is 1. Subtract 1 from both sides. We get that x squared equals 3. So we take the square root of both sides. So we get x equals root 3. So this is now our exact value triangle or special triangle that we can use to find lots of different trig values for. And we call these exact values because because we've got a square root, so that's going to give us an exact number. So for example, I could find sine 60. So this is without using my calculator now. So I go to the angle of 60. Remember, the trig ratios are always from the angle. And I go to the 60. And I know from my SOHCAHTOA that sine is opposite over hypotenuse. And so that means I have root 3, because that's the opposite, the 60 degrees, over the hypotenuse, which is 2. If I try another one, I could do tan 30 degrees. And so tan is TOA, so that's opposite the angle of 30.
Yeah, and this time it changes because it's the 30, so this one becomes the opposite.
And so now I have 1.
And this is the adjacent, so it's 1 over.
And then the adjacent side, which is root 3. We could do another one if I do cosine.
Let's change colour, so let's pick purple. So cos of...
Let's do cos of 60 as well. Let's see what happens there. And so again, we go from the angle. Cos is ka from the SOHCAHTOA, so adjacent over hypotenuse. And so my adjacent side is 1 and the hypotenuse is 2. So cos 60 is 1/2. So you could try all those in your calculator. Of course, the ones that have the root 3 in it will give you a big long decimal. But if you do root 3 divided by 2, you should see that you get the same answer. So we're doing this without a calculator. If it says exact values, it means you should have used these triangles.
So you can use this triangle to find the sine, cos and tan of 30 and of 60 without using a calculator.
Yep.
Yep. Okay, shall we look at the other triangle now?
Yeah.
The other shape?
You're going to have to close it.
Oh, there we go.
There you go.
Okay. Oh, let's get rid of a random line. Okay. Right, so if we go up to the top, this one starts with a square. It's a 1 by 1 by 1 square. If we split it through the middle, this angle bisects and they're 45 degrees. And very similar process, we're going to use this triangle to help us find sine, cos and tan of 45. So let's label as much as we know. We know that this is 1. We know that this is 1 as well because it comes from the square. If we use Pythagoras, so let's call this, in fact, let's already call it the hypotenuse as well. And let's call it x. So using Pythagoras, x squared equals 1 squared plus 1 squared. X squared equals 1 plus 1. X squared equals 2, so x is root 2. So the value of this is root 2, the hypotenuse. We know the angles, they're both 45. This is an isosceles triangle. Okay, so let's think of one of the trig functions which we could use. Let's go for sine 45. So sine 45, I can pick either of the two angles. I'm going to pick this one. It means this is the opposite. And this is so I want the opposite and the hypotenuse. This is the hypotenuse. The hypotenuse doesn't change, it's always the same one. So opposite is 1, over hypotenuse, which is root 2. Okay, and let's go and find tan, for example. So tan 45, again, I can start with this angle here. That's the opposite. This is going to be the adjacent. And opposite over adjacent, 1 over 1 is 1. Okay, and I could do the same to find cos with the same process.
So we would really recommend that you remember these two triangles. Instead of remembering, sometimes people remember what sine 60, cos 60, tan 60, etc. is. That's a lot to remember, so I think it's a lot easier if we can just remember the two triangles. And it helps to remember where they came from. So the one with the 45 comes from a square, and the 60-30 triangle comes from an equilateral triangle.
Yep.
Okay, shall we put